What would you say is the most recent innovation that we've all heard about?
To me, I think there is this subset of error correcting codes known as QLDPC codes, quantum LDPC codes, which have very nice theoretical properties that has great implications on error correction, and it makes the resources required. Because at a high level, the way error correction works is you have a lot of noisy qubits, and you essentially use like 100 noisy qubits to maybe simulate 2 or 3 perfect qubits. That's the rough idea of error correction. And I think QLDPC codes, the rate, which is the number of noisy qubits you need to simulate a certain number of logical qubits, that's quite high. So they are quite appealing to me. So that to me, I think that's one of the most interesting areas that I'm looking. And QLDPC again. LDPC codes are not new. These were first discovered in 1967, and they are used currently in 5G communication in our mobile devices. So now the quantum version of these LDPC codes are sort of one of the things that many people believe is state of the art.
Interesting.
So yeah, error correction, like classical error correction, is what enabled classical computers to function, basically. But yeah, nowadays it's basically everywhere in all wireless communications, in something as simple as a CD-ROM in hard drives, even the transmission over the internet that has a certain notion of error correction inbuilt. So now a lot of these same principles have been translated over to quantum computing. And in fact, most of the codes that are being sort of researched now, they had their origins. They are classical codes at the end of the day, but they have been extended to work in this, because in the classical codes you just have one sort of error, a 0 changes to a 1 or 1 changes to a 0. But on a quantum computing, you also have this phase, which is you can have essentially a continuous phase as along with the bit flipping between zeros and ones. So fancy way of saying you have more errors to correct. So your codes have to be much more complicated than just the classical error correcting codes.